In this presentation, we are going to look at integration by parts, and this is the second of a series of presentations I have on this subject. So first off, let's look at how we will conduct ourselves with integration by parts. What we have here is an integral u dv, the integral of u dv, and what we have here are two component expressions here. We have u and we have dv. What we have to do is evaluate these two additional expressions down here, v and du. We get that by first v is evaluated by integrating dv, and du is evaluated by differentiating u. So then we would put it all together in this expression here. We put all the resultant terms. We might have to carry out a second integration here. It's usually much simpler than the first, and that would give us our answer. So let's look at an example here. We have the integral of 2x log n dx. Now, we are not bound to use x as the u term. We can actually in this case it's actually simpler to work with log n of x and have that as our u term and differentiate that. It's much easier. So let u equal to log n of x, the natural log of x. Du dx is equal to 1 over x. That would be found from statistical or mathematical tables. And finally, cross multiplying that last expression there, we would have du equals 1 over x dx. So those are two of the expressions we would need, u and du. Let's get v now. In this particular case, we're going to let dv equal to 2x dx. And what we're going to do to evaluate v is integrate both of those. So we have v equals x squared all over 2 plus c. Now we can I put in the coefficient of integration here, but what I can do is sort of disregard that and leave that till the end. So for the time being, we're just going to use x squared over 2. At the end of the entire calculation, we'll put back in the coefficient of differentiation, c, or integration. So what we're going to do now is put all this together. So we have the integral is equal to u, which we know to be log n, natural log of x, times x squared over 2, and that evaluates as x squared. So that's uv there. I've actually put it in reverse order because that's how we might write that in that particular case. So what we have to do is evaluate v du. So v is x squared, and du is 1 over x dx. Sorry. So what we're going to do there is actually simplify this. That's minus integral of x dx. We can actually simplify x squared times 1 over x as x, simply x. Okay, so the expression we have on the next slide is what we had where we're at right now. So the last part of the expression is simply we have to perform this little calculation here. We found the integral of v du to be the integral of x dx. So essentially what we have to do is just perform that last little calculation there. So we have x squared log of x minus x squared all over 2. Now we put in the coefficient of integration there because this is now our final full answer, and we have solved the problem. There it is there, and that ends